All right. Well, welcome to NEBR's 23rd Quarterly Northeast Digestion Roundtable meeting. Our guest today is Adam Lorette from Ishigaki. I believe he also brought some folks from, I know he brought some folks from West Core along with him. I recognize Bill Montanaro Jr. And so this, just for those of you who haven't participated before, this isn't really a webinar, but more of a meeting or a roundtable format. We are going to have a presentation and then open it up for questions and discussion. And I know the presenters value the feedback that they get from all of you who design, operate, and permit these anaerobic digesters. I'm just going to ask you to stay on mute during the presentation, but then we can open it up for questions and comments after that. There is a chat function, should be at the bottom of your screen, which I'll keep an eye on. So feel free to put questions in there as they come to you. We are recording the session, and I'll put the link to the recording along with the slide deck from Adam on our Netter page after this is done. So today our topic is dewatering, and I learned early on from some NEBR members who manage Digestate that this is a particularly tough material to dewater. So what we have today is an expanded version of a presentation that was given at WEFTech earlier this week by Adam Lorette of Ishigaki, USA. And Adam is the technical sales manager for North America for Ishigaki. He graduated from Worcester Polytechnic Institute in Massachusetts. He has a bachelor's degree in chemical engineering. And after a short stint in the oil industry, he's been focused now on selling Ishigaki's state-of-the-art line of dewatering equipment, including their screw press and the Lasta filter press. And outside of his professional life, he enjoys playing basketball, watching football, running, and listening to live music. He works out of Ishigaki's new Portsmouth, New Hampshire office, and I understand that you also have a manufacturing facility in Maine as well. So with that, I'm going to ask Adam to go ahead and take over the screen sharing and take it away.
All right, everyone see that now?
Yes.
Okay. All right. Well, thank you for the introduction. As Janine had mentioned, I'm Adam with Ishigaki, Technical Sales Manager. We're based out of Portsmouth, New Hampshire. And we do manufacturing for our screw press up in Maine as well. So, yeah, it's a Japanese corporation, which we'll talk about here in a minute. But I'll be presenting today on improving sludge dewatering performance with the Platinum system. The weather seems to have gotten better, but I know right around us there's been some losses of power, so hopefully we get through that. But if I cut off for some reason, that's why. So yeah, so we sell screw presses and manufacture screw presses in North America, mostly in the municipal market. And then she mentioned our Lasta filter press, which is, you know, dewatering as well, but typically used in the mining sector. So we'll jump right in, I think. So we'll get started with basically an agenda of today. And again, this was presented at WEFTech, so excuse the WEFTech headers and everything. But first, we'll start off with a little background. You know, what is the issue that we're trying to solve? Then we'll get into a little technical overview of how we are trying to solve or mitigate that issue. Then move into previous results. And this was really the majority of the presentation last year at WEFTech, not a couple days ago, but last year. And that's really focused on lab scale and pilot scale results. And then we'll move into results from our full scale installation, which was installed in April of last year. So we have 1 year of operating data to look at. And then we'll just get into a conclusion from there. So off to the right is a little animation, I suppose, from our full scale installation. You know, skid mounted. So, all right. So background in Japan and increasingly elsewhere globally, really, you know, items like limited landfill disposal space has made disposal costs or tipping fees a lot more expensive, and that continues to get more and more expensive. Energy costs, which we've all seen in the past, you know, specifically in the past few months, increased significantly. This goal of carbon neutrality, you know, there's a list of other items, but basically, because of these items, there's been increasing use of anaerobic digestion globally, really. By and large, in a lot of scenarios, anaerobic digestion is, a very good thing, but there are some downsides to it. One of which that we'll be talking about today is basically the dewaterability of anaerobically digested sludge. So it's relatively difficult to dewater compared to other types of slurry at municipal wastewater treatment plants. Because of the difficulty in dewatering this, this can, best case scenario, just have a large operating expense for these plants, but for like new projects, it can really affect project economics. So in general, there really is a need to improve the dewaterability of anaerobically digested sludge. So one way that's been studied historically, there's a few specific studies at the bottom there, but one way to improve dewaterability is to use fiber. Things like pulp fiber, bagasse fiber, synthetic fiber are all approaches that are currently being used, and they're very effective. And there's been studies done on those, and they're in full-scale operations right now. Problem with these fibers is they're coming from an outside source, and they can be quite expensive to purchase and to move onto site. Ishigaki's been in the municipal wastewater dewatering world for quite a while. There's a lot of knowledge there, and what we've found over the 30 years of experience here is that influent sludge to a typical municipal wastewater plant, has a significant amount of fiber in it. So the goal of this system is really to use the existing fiber that is at plants as a dewatering aid instead of purchasing external fibers. So there's a couple of pictures of some fibers that have been used, and then to the right you can see basically the fiber that we would try to recover from the wastewater plant to reuse as a dewatering aid. So again, that's already at the plant and it's there. We're just trying to use it. So as a dewatering manufacturer, I speak pretty easily about fiber content and slurry. So this slide's included really to just provide some context on what is a typical fiber content and how does that relate to cake solids. So our dewatering performance, specifically here, cake solids. So the three subsets of sludge that we typically look at in the municipal wastewater world is waste activated sludge, anaerobically digested sludge, and blended sludge of WAS and primary that has not been anaerobically digested. So the typical range of fiber content for waste activated sludge is about 3 to 5%, so extremely low. Typical cake solids you'd see off of a municipal or mechanical dewatering piece of equipment will be in that range of 15 to 18%. So very, very difficult. Anaerobically digested sludge, which is what we're focusing on here, fiber content is about 5%. You see typically anywhere from 18 to 20% cake solids off of dewatering equipment. And then for blended sludge, fiber range is typically in the 20 to 30% range, and you see about 25 to 35% cake solids. This isn't like a formal graph, but this is just from my personal experience in dealing with this in the United States. So those are some rough numbers to give you some context around fiber concentrations. So the first thing that was done by Ishigaki was, can you grab that? I'm sorry. Was to look at primary sludge at 22 different wastewater treatment plants in Japan, and basically measuring the fiber content. And the way we measure fiber content is basically just whatever solids get stuck behind a 100 mesh screen. All that stuff, in our opinion, can be used as fiber for dewatering aid. So at 22 different plants, varying throughout the year, the average fiber content in the primary sludge was approximately 45%. So this really told us, and looking at the previous slide, just looking at blended sludge in general, that there is a significant amount of fiber in this sludge, and it can be a suitable source for recovery as a dewatering aid. So knowing that there is a significant amount of fiber and it can be used as a suitable source, now we're trying to figure out, how do we do that? And is it going to be cost effective? So now we'll get into a little more detail of what we refer to as our platinum system. So here's a very, very simple flow diagram of a typical plant that utilizes anaerobic digestion. The two flows that we'll be really discussing today are the primary sludge coming off of a primary settling tank or a primary clarifier, and the digested sludge, which will come out of the digester and typically go to dewatering. So these are the two flows we'll be talking about. And this is the same flow diagram, but kind of gives you an idea of where our platinum system fits into the mix of the whole plant. So really the goal of this system is to take primary sludge, run it through what's shown here as our recovery unit, which is the main component of the platinum system, and separates out fiber from the remainder of the slurry. And the fiber can be used as a dewatering aid just prior to the dewatering equipment, and the remainder of the sludge will go back into likely a thickener or something upstream of the anaerobic digester, and then go through the digestion process. So the components of the platinum system, it's made up of various tanks and pumps. That'll vary site to site, but the main component is the recovery unit, and that's made up or comprised of two pieces of equipment: the sludge mill and the recovering device. So the sludge mill basically grinds down all of the solids and allows for effective separation of the solids, and then the recovery device takes the ground up solids and separates out the fiber and the remainder of the slurry, and then washes the fiber so that it can be recovered and used as a dewatering aid. So again, another very simplistic flow diagram. A couple of pictures from our full-scale installation. So there's a sludge mill on the left and the recovery device on the right. And the recovery device acts very similarly to a screen. So solids will go through there, liquids and smaller particles will go through the screen, and that'll get sent back to the anaerobic digester. And the larger solids, which we are referring to as fiber here, will come out the end in a slurry form and can be pumped into the dewatering process. So now we'll go into the previous results. So this is mainly lab and pilot scale results. And again, we presented on this last year at WEF, and there was a year of data of pilot scale results that we'll cover here. So, so the first thing we looked at was how much of this fiber that's in the primary sludge are we recovering, and the purity of the recovered slurry. So in that slurry of the solids, what is fiber, and what portion of it's fiber compared to what portion of it is not. So you can see the equation there, which is pretty self-explanatory and pretty intuitive, but yeah, so we don't need to go into too much detail there, but basically how much are we recovering, and of the recovered solids, how much of that is actual fiber. So a couple of plots based on the pilot scale data shows us that we were able to recover 85% of the fiber, and in the slurry that was recovered, about 85% of those solids were fiber. So the y-axis on the left graph is the recovery rate of fibers, and the y-axis on the right graph is the purity of the recovered fibers. And the x-axis on both of these are the total solids. So basically, at what rate we were running the platinum system. So you are able to control that, but what we thought was a pretty good sweet spot was at this 100 kilograms per hour. So approximately 85% purity and 85% recovery was shown at the pilot scale level. So now the important stuff: we recovered the fibers. How did this affect dewatering performance? So here's another very simplistic flow diagram of the dewatering system. Kind of just gives you an idea of where we're introducing each of the flows. So the main flow coming in is the digested sludge. So typically that would just get pumped into the conditioning tank or a flock tank. And normally you would add polymer, which we are still doing here, but just upstream of the polymer addition, we introduced the recovered fibers. So that's slurry of washed fibers. And went into a conditioning tank and went into a screw press. These were all done on Ishigaki screw presses, obviously, because that's what we manufacture. So how did this affect dewatering performance? So very promising results here. X-axis on the left graph is the addition rate of recovered fibers. The y-axis is cake solids concentration. So as anticipated, with increasing addition rate of recovered fibers, we saw an increase in cake solids, which is exactly what we wanted to see. And it fit, a best fit line very well. So it was accurately modeled and should be, easy to understand what you can expect. So if you look down here toward the 0 addition rate, so no fibers are added, you're in that 18% cake solids, which is, what you'd expect if you didn't add fibers. And normally what you see for anaerobically digested sludge is about 18% cake solids. And as you add fiber, you work your way up this curve. This 0.5 to 0.6 addition rate is really what we anticipate as recovering as much of the fiber as possible at a standard municipal wastewater plant. So what we're really anticipating, if you are able to recover all the fiber at a plant, is somewhere in that 30 to 35% cake solids. So, it's a significant increase in cake solids from 18% to 30%. It's significant. Increasing cake solids is great, but at the end of the day, there needs to be some justification for this. It's easier operationally and everything, but what really moves the needle is reducing the volume of sludge that needs to be dealt with by the plant. So if you're hauling this to a landfill, it really reduces the volume that you have to transport to a landfill and then pay for tipping fees. So this is maybe a little bit counterintuitive. It's not a 65% decrease in volume, but I guess a 35% decrease in volume. So about 65% of what the initial volume would have been without the platinum system. So there's a huge decrease in volume of solids that needs to be disposed of or hauled somewhere, depending on what the end use is. So, we talked about the advantages. There is a downside to this, and basically we wanted to look at the effect of digestate gas. That gas is very commonly reused to power a plant. So what we did on a lab scale is basically took 2 5-liter tanks, used those as digesters, had a 30-day acclimation period, a 35-day evaluation period, and basically just do a side-by-side comparison. Case 1's the control. So we just put anaerobically digested sludge, or put sludge in there and digested it. And then case 2, we removed 75% of the fibers and, adjusted for volumes and things like that. And basically compared them and measured daily. And what we saw was basically a 20% decrease. So assuming you recover the majority of those fibers, you can expect a 20% decrease in digestion gas production. So something that definitely needs to be considered. I'm not an expert on digestion gas, but what this table is really trying to show is that the composition didn't change. It was just a reduction in volume of production. So something that needs to be considered for sure. So that was the lab scale and pilot scale information. And then, like we mentioned, April of 2021, we installed a full scale installation. So the next section will be covering the full scale installation. So full scale installation was installed in southern Japan. I mean, obviously our headquarters is in Japan, so a lot of this R&D work is done in Japan. So very southern end of Japan, the town or the city is called Kumamoto. So this was done at the Kumamoto Southern Purification Center. They have 5 plants in Kumamoto, so this was installed at just one of them. Design capacity is 14.6 MGT and average daily flow is about 9 MGD to give you some idea of the size of the plant, so quite large. liquids treatment, typical conventional activated sludge system, very similar to what you'd see here in the US. And solids treatment, thickening, pretty typical digestion, anaerobic digestion process, and then into dewatering with a screw press. So again, pretty similar to what you'd see here in the US. Technology used was the screw press. It was Ishigaki screw press, and average cake solids concentration prior to installation of the platinum system was about 19%. So again, pretty typical of what you'd see here in the US as well. Cake disposal here was beneficial reuse. So went to a cement plant and was used as feed to manufacture cement. So operating conditions, we won't spend too much time on this, but the goal of this slide is just to validate the data, basically saying, you know, there's plant influent for 2018, 2019, 2020, and 2021, and the sludge production. And August was a bit of an outlier, but in general, year on year, it was very comparable. So we wouldn't anticipate any flawed results because of something weird that happened at the plant. It was pretty stable throughout the past 4 years. So now, effect on cake solids. 2018, 2019, and 2020 are, actually, let me start. The x-axis is each month, and the y-axis is cake solids concentration. So the green, gray, and blue curves are the 3 preceding years of cake solids, the average per month. So you can see it's pretty stable. There is some variability, but right around 19%, like we had mentioned on the previous slide. Then after installation of the platinum system, you can see it jumped right up to 24.5% on average. Now there's a couple important items to pull out of this slide. You know, first off, obviously there's a 5 percentage point increase, which is, you know, significant. But there's a dotted line here, which is basically the maximum allowable cake solids that the cement plant would accept. For 2 reasons. One was contractually, the plant needed to supply them with 20% cake solids plus or minus 5 points. So they were really limited contractually at 25%. And the reason for that being the cement plant uses an incinerator, and over 25% had some adverse effects on their incineration process. So the goal of this platinum system really was to achieve as close to 25% without going over. So you can see, you know, they really were able to dial this in and average 24.5%. And you can see it's very, very stable relative to the previous years. So they're able to control it very well and able to achieve very close to that 25% without going over. So, you know, very promising results from that. So this is a graph that we looked at earlier in the presentation, but the x-axis is the addition rate of recovered fibers, and the y-axis is cake solids. So the red dots here are the actual data from the full-scale installation put on top of the previous graph that we had looked at. And you can see the full-scale installation data really aligns well with the regression curve that was put in here, and matches well with the pilot data. So the model seems to tell us that it's working very well and it's accurate. And again, we were limited at 25% cake solids, so it was really operated in this range. And it's, you know, we fully expect that if you were to increase the recovered rate of fibers, you know, we'd be up in that 30 to 35% cake solids. So again, very promising results, which was great. So again, cake solids are great, but the volume of solids is what we're trying to reduce. So here's a graph comparing the 3 previous years by month of the wet solids or dewatered sludge production in tons wet per day. So there's about a 22% decrease in wet sludge that needed to be transported from that plant to the cement factory. So, you know, that's really the kind of thing that will move the needle on the economics for this process. So again, 22%, which was very promising. Something that doesn't really move the needle, but you know, very helpful for the economics was the effect on polymer consumption that was found. with the more fiber you have in a sludge, the easier it is to dewater, and the easier it is to dewater, the higher cake solids concentration you're going to get and the lower polymer consumption you're going to need. So polymer consumption also decreased around 22%. So again, not really going to move the needle, but definitely something that needs to be considered and will certainly help the economics. So again, very promising results. Now, effect on digestion gas, again, one of the disadvantages of this system. And again, we were limited at 25% cake solids. So, I think this number would be larger on a full-scale installation that didn't have that cake solids limit. At this plant, all of the usable digestion gas was really used to power the plant. But they saw a 5% decrease in digestion gas. So we know that because we measured it, but it didn't really affect the plant. I didn't see anything on their side that was noticeable. So I would say relatively minimal impact on digestion gas, specifically at this plant. That would likely be larger if there wasn't that cake solids limit. But again, something that just needs to be considered. But again, still very promising results. So, and the reduction in digestion gas is plotted here against the lab scale data that we had. And again, just kind of showing that this really fits the model very well. So we feel we can accurately estimate what the reduction of gas will be depending on how you operate. And, if 100% of the fibers are recovered, we anticipate you seeing a decrease in digestion gas of about 20%. So now the important stuff. All this stuff's great, but what does this look like looking at dollars and cents? So on the left is before installation of the platinum system, and on the right is after installation of the platinum system, and the y-axis is O&M costs for sludge disposal specifically. So you can see a small decrease due to the polymer, which we talked about, and really the lion's share of the decrease in operating expenses is from sludge disposal. So that's the blue color here, but significant decrease there. This amounted to about $223,000 in US dollars, and that was about a 19% decrease in operating expenses. And again, if the cake solids limit there, we'd fully expect that to be a lot larger of a number, or a lot larger of a decrease. So there is some added maintenance on here as well in black, but it's very minimal. Everything's still relatively slow moving equipment. So in greenhouse gas emissions, this is going to vary significantly site to site, but at this plant, the majority of the greenhouse gas emissions were due to, I believe, the incinerator at the cement site. So being able to operate that more efficiently at the 25%, there's a large decrease in greenhouse gas emissions. There's also some decrease contributed from transportation, so hauling those solids from the wastewater plant to the cement site. But you can see a 21% decrease in greenhouse gas emissions was calculated. So in conclusion, after a full year of operating the platinum system, it was proved that there was an improvement on the dewaterability of the sludge. This resulted in reduced polymer consumption and increased cake solids concentration. Due to the increase in cake solids concentration, there's a reduction of volume of dewatered sludge that needed to be handled by the plant. Because of that, there was a reduction in operating costs and a reduction in greenhouse gas emissions. So all very promising results. There was a cake solids limit, as we talked about multiple times, by the cement manufacturers, which really suggests that improved performance and improved economics are possible. I would probably say highly likely, not possible, but there's room for improvement there for sure. Widespread use in Japan is likely at this point. The plant that we installed this at has expressed interest in installing it at some of their other plants that they have. And I believe we have, I think, 2 or 3 orders from other plants within Japan now at this point to install the full-scale system. So it's becoming more and more popular in Japan, and you know, we're in the process of deciding if we're going to roll this out elsewhere globally. Yeah, so that's kind of where we're at. There's a quick video here. We won't really go through much of it.
Purification Center is responsible for sewage treatment in the area centered on the southern part of Kumamoto.
But basically, just this video kind of gives you an overhead video and view of the installation, the plant, and there's an interview with the end user that kind of goes through his experience there, and everything was very positive, which we can play afterwards. So I'll just play up until the end user starts talking, so you can get some video action of what it looks like, the installation.
Purification Center is responsible for sewage treatment in the area centered on the southern part of Kumamoto City, which started operating the Platinum system in April 2021. One recovery unit was installed and is producing dewatering aid for 3 dewatering systems.
The city is actively working on the reduction.
So I'll stop it there, but he talks for a couple minutes and everything's very, very positive. So I think that really concludes the presentation. So I'd love to, you know, discuss what your thoughts are. Anyone who has any input or feedback or anything like that, you know, we're looking to hopefully roll this out here in the States. So any feedback you guys would all have or questions or anything like that would be appreciated.
Yes, so I have a bunch, Adam, but I don't want to hog and actually some of them you answered as because I was questioning about polymer use, wondering what the decrease in that might be. So in the one of the first diagrams that you showed of the process, you're pulling out fiber from primary sludge. You mentioned washing it, but I'm just wondering if there's any concerns with bacterial, any kind of contamination issues coming directly from primary.
I mean, I wouldn't think so. Yeah, I don't know if I can really answer that. I wouldn't anticipate that. I know bringing solids that haven't been digested back into that flow can cause some concerns, and most of those, I guess most of the questions I've received on that have been like, hey, how does this affect, you know, part 503 classification of the solids?
Yeah.
You know, and again, this was rolled out in Japan where that's not a concern at all. And it is something that we are in the process of going through here in the States, because it's definitely a consideration if we're going to roll this out here in the States, but really haven't gotten there yet. And I think there are, you know, applications in which you're going to a landfill or you're going to incineration or something like that may not be a concern.
Right.
But I'm sure, you know, that's something we need to look at in more detail.
Right.
For sure.
Have you looked at all at co-digestion systems, using this with co-digestion? Because that could certainly offset the decrease in digestion gas. As generally mixing food waste with biosolids will definitely ramp up your gas production.
Yeah, no, we haven't. And hopefully that's something we will look at here shortly. We have an installation up in the Montreal area, which does do co-digestion, and that's one of the targets we've looked at. So we haven't seen how that'll affect anything, but hoping in the near future. You know, it's an Ishigaki screw press installation. We're very friendly with that end user, and they're happy with everything. So it's something that we hope to look at, but I don't know. I think those, in my experience, those plants are kind of hard to come by sometimes. So hopefully.
Yeah, currently I would agree, but hopefully we'll be seeing more and more of that. So that's great. You're gonna take a look at that. That'll be questions people will have for you going forward. Let's see. I know Don had to run. Any other questions from anyone?
Hi Adam, this is Brendan. Have you mostly been focused on municipal digesters?
Yeah, for the most part, for this specific product, yes. I suppose a lot of the industrial applications have limited fiber coming into the plant, so it may not be as useful if the influent to that, whichever, industrial plant has significant fiber, it's definitely something that could be looked at, but the fiber content in municipal slurries, in my experience anyway, typically has a lot more fiber, which, from toilet paper, things like that.
Yeah.
So I think it's
What
just
about what about like dairy farms that have fiber in the waste as well?
We have a couple installations on dairy applications, and it's been very minimal fiber in all of those.
Okay.
So, like for instance, I started one up probably maybe like 4 years ago now in California, and that's a pretty big operation. It's got an activated sludge process, and the fiber. I think we measured the fiber in their primary, and it was like, I want to say like 10% or something like that. Relative to, like the municipal, we're seeing like 45%. So I think it's just a question of how much fiber is there. And, if there's a question like that, for sure, we can run all that testing. That testing is very easy to do, and we do it pretty regularly. So if there's an application like that, I'd love to talk in more detail, probably at another time. But yeah, it's just a question of how much fiber is on the influent. So.
Okay.
Yeah, very interesting.
Just in terms of some of those other waste streams you may deal with, do you ever partner with other companies for further downstream treatment of the liquid portion of anything? Or are you guys primarily just focused on that slice of the pie with removing the fibers?
Yeah, I guess mostly the liquid portion of the primary, or which liquid portion? Sorry.
Post your process. Is there any other further polishing that is needed, or for overall project designs?
Yeah, I mean, that's the liquids coming out of I guess the liquid coming out of the dewatering plant typically just goes back to the head of the plant for reprocessing. So we typically don't touch that. We have like polishing filters as part of we don't really sell those much in the US, but globally we do sell that a little bit of that, but very common. I would say we sell those mostly in the mining industry. So yeah, typically that just goes back to the head of the plant's reprocess. So we don't see a need for that typically.
Okay.
Yeah, I don't have any other questions here, Adam. Anyone else? I know Zwitterco. Well, since we have some time, maybe Brendan, you could just talk a little bit about what you guys are working on.
Yeah, we've
for
been
anaerobic digesters, because I'm always looking for good topics.
Oh yeah, sure. So we don't really work on the municipal applications like Adam is, but we've been working on basically after they dewater, we've been taking the filtrate or centrate, depending on what the dewatering equipment is, and then using it or then putting it through a membrane process and recovering the nutrients from that stream.
Oh.
And we have we're partnered with Digestion Organics, which you've talked to before.
Yes, we have.
So that's one of our North American partners, and so we have a large installation that's coming online they keep pushing it back because of supply chain issues, but that's coming online in January. So that will be like our first big commercial installation, but it's like
where is that?
It's in Wisconsin.
Okay.
It's
a dairy farm, on a dairy farm.
Yes, it's I think it's the third largest digester in the country, or dairy digester in the country. So it'll be a big project. But
good luck.
That's why Jake was asking Adam about the back end of after the sludge dewatering. We haven't really looked into municipal that much yet. It's a little bit different than the dairy side.
Yeah, and it sounds like it is from the fiber perspective as well,
Yeah.
which that wouldn't even have occurred to me, but yeah, it makes sense now.
Yeah.
Now that Adam's talked about it.
Yeah. So just curious, was that your first installation in the US for Zwitter?
Yeah, for Zwitterco, that's our first, well, yeah, that's our first installation. We've done some piloting in other places in the US. We have like a small installation in the Netherlands on a hog farm. We have other installations in other industries, but Digestate, that will be our first big installation in the US.
Nice.
Congrats on that.
Yeah.
Thanks. I'm excited for it to come online because I haven't even seen it yet. So,
yeah, I mean, historically around here, I keep trying to get to the bottom of why anaerobic digestion at wastewater treatment facilities is not more prevalent. One of the treatment facilities I ran in Warwick had double digesters that were installed in the 60s when with federal funding, but the superintendent pretty much shut it down once we got stringent nutrient permit limits. I know they're tough to operate, but I would think with the price of energy around here that we'll hopefully see more of it going forward.
There's like there's a company. Have you talked to Vanguard Renewables? They're based out of Waltham, and they have been making a lot of like food waste digesters in New England. They have a few projects in like Vermont and Maine, which seem cool. But I know that, like you were saying, how there's codigestion is becoming more popular. I know that like a lot of the people we've been talking to have been food waste digestion focused, especially recently, which is cool.
Yeah, no, I agree. So that, and that's great that Adam's going to take a look at that.
But yeah, Vanguard, you should see if you can get in contact with Vanguard because they're a New England company.
Yeah, no, thanks for that tip, Brendan. And there's also our friends at UConn, which hopefully I'll get them back in 2023 to talk about this research project that we're working with them on, basically using AI and machine learning to set up a SCADA system, basically to operate digesters.
I was at that.
Maximize the gas production and safety. So that could be a game changer.
Yeah. We went to, Jake and I went to a conference recently, Renewable Natural Gas Works in Nashville. And like, it seemed like half the companies there were biogas upgrading. They had biogas upgrading systems. That was cool to see.
Yeah. So I think some of those things too, Adam, can counter the decrease in gas digestion that happens from this, especially if the economics work for reducing the volume is going to be key. Everybody's going to be focused on that in the short term.
Yeah, for sure.
And that's another reason why you would use anaerobic digestion, right?
Yeah. Yeah.
And the energy production's a bonus. But I am hoping I see a rosy future for some AD projects in this region. And so all of you that are working in this area, we all wish you the best of luck in promoting all your products and improving the processes. And I mean, unless you guys want to chat some more, I'll just thank Adam so much for this very interesting presentation. He answered a lot of questions I had about Digestate dewatering. And thanks for all of you guys for participating as well. Brendan's always engaged here. I'm lining up topics for 2023. So if you have an idea or you want to do a presentation yourself there, zwitterco, let me know as I'm setting these up. You can also suggest a topic on the web page with a click of your mouse. So
cool. Thanks, Janine, and thanks Adam for presenting today.
Yeah, of course. Thanks for having me. Appreciate it. It worked out well since I just did this at WEFTEC. And
yeah, all polished.
Yeah, and I incorporated all the questions they had asked into this presentation. So probably
that's why we didn't have as many questions.
I had a heads up beforehand. So.
No, but that's good and it's helpful. I think that's part of what I like about these roundtables is that some vendors with new products, new ideas can get some really concrete feedback from guys who operate them and design them. So
yeah. Well, hopefully, a year or two from now, we'll have a installation in the US and we can rehash this.
And then come on back again and tell us all about that.
Of course. Yeah. So thank you everyone as well for listening to me chat for half hour or so on a Friday afternoon. So
Yeah, no, definitely fun. And I will be posting the recording on our Netter page, and I'm hoping that the folks that weren't able to join us that signed up can access it there and learn all about it.
Thanks.
All
Adam.
right.
Thanks, Janine.
Thanks,
everyone.
Adam.
Thank you.
Hey, nice to meet you. Have a
Hey, thank
great
you, everyone.
weekend, everyone.
Take care.
Happy
Bye.
Friday. All right.